Okay, so moving on to the next question. Which will result in a perfect square trinomial? So a perfect square trinomial is that which can be written. So let's assume two cases of perfect square trinomials. So let's assume this case of ax minus b squared and ax plus b squared. So these are two common cases for a perfect square trinomial. If we were to expand both of these out, we would get a squared x squared minus 2abx plus b squared. And then expanding this out, we would get the same thing, but this minus sign becomes a plus sign. And this is essentially what it has to look like in this form. So this a and b has to exist in order to make it a perfect square trinomial. So if we go through each answer choice, we can expand them out and see if it fits in that same format. So for the first answer choice, we're going to have 3x minus 5 times 3x minus 5. And expanding this out, we get 3 squared x squared minus 2 times 3 times 5x plus 5 squared. So there's a reason why I didn't actually evaluate like 3 squared and 5 squared, for example, because I want to see if this matches the same exact format as any of these examples of perfect square trinomials. So in the case of a equals 3 and b equals 5, we see that this actually lines perfectly up with this ax minus b quantity squared example. A is 3 in here, then 3 and 5 because b is 5, and then plus 5 squared or plus b squared. So we say yes, this answer choice is a perfect square trinomial. Then going on to the second answer choice, we have 3x minus 5 times 5 minus 3x. And let's expand this out again. So actually we can write this in a different way. So we can write this as 3x minus 5, and we can actually factor out a minus sign out of this term here, so like a little hack. So I'm going to put this minus sign on the outside here and get 3x minus 5, and that essentially turns this into a perfect square trinomial as we found in this example. So what we would get is minus 3x squared x squared. Oh, my apologies. It would be 3 squared x squared minus 2 times 3 times 5x plus 5 squared. Alright, and this as well would also be considered a perfect square trinomial because it can be refactored back into minus 3x minus 5 squared. So because it suffices the same condition that was met in the last part, then yes, this is also a perfect square trinomial. So moving on to the third option, we are going to have 3x minus 5 times 3x plus 5. And right off the bat, this is a case called the product. So when we have so let me first do this product and then I'll explain. So we're going to multiply these out and we're going to get 3 squared x squared minus 2. So no, there's not a minus 2 in this case. So because of these different signs here, we have to consider the sum of the products differently. So we're going to get minus 5 times 3x and then plus 5 times 3x, and then we're going to get minus 5 squared. So first thing to notice is that this term right here, this is the inverse, or sorry, the negative version of this term, so this is just equal to 0. So for that reason, what this really evaluates to is 3 squared x squared minus 5 squared. And this is not of the form of a perfect square trinomial because we are missing the x term. So for that reason, we can rule this out and say no, this is not a perfect square trinomial. And finally, our last answer choice, we can look at 3x minus 5 times minus 3x minus 5, and we're going to use a similar trick to the one that we used for the second answer choice, and we're going to factor out this minus sign here. So we're going to get minus 3x minus 5, and then factoring out this minus sign, we got 3x plus 5. And because this exact product was not a perfect square trinomial the first time around, it is not going to be one again just because of this minus sign. So what this really is minus 3 squared x squared minus 5 squared, right? And for that reason, this is not a perfect square trinomial. And what this is an example of is the difference of perfect squares. So this 9x squared and this, so if we consider this as 9x squared minus 25, this is a classic case of difference of perfect squares. So what this is the product of 3x minus 5 times 3x plus 5. This is a special case, and it's never ever going to be a trinomial. So both of these will not be perfect square trinomials. And that concludes this problem, and this solution is correct. It agrees with every part. And I'm going to say that they did a great job, and that concludes that question.